Question 8, Jan 2009, quarterly paper. Write down the coordinates of P and Q for the inverse cos graph. Well, it's -1 along, pi up for P. So we'll write down -1 pi. And for Q, it's 1 along, 0 up. So Q, 1, 0. B, part B, describe the sequence of geometric transformations that map y equals inverse cos x onto our required function. So we'll do it step by step. Y equals 2 cos inverse cos of x, and that would be a stretch scale factor 2 in y direction. That'll be our first transformation. Our second transformation will go from y equals 2 cos inverse cos of x to y equals 2 inverse cos of x minus 1. So our second transformation will be a translation. Important to get the word in. Translation of, it's 1 to the right, so 1, 0. Part C. Sketch this function here. Well, use our transformations to help us sketch it. We're given inverse cos of x, so 2 inverse cos of x is a stretch by 2 in the y direction. So I'll make this point pi and the top 2 pi, and then move it 1 to the right will give us our actual answer. This is point 1. So the 1 will go along to 2, and the -1 will go to 0. So we put this as 2. I put this in here as pi. And this is 2 pi. So it's clearly marked where it intersects the x and the y and the x-axis. Part D. Write this equation in the form x equals. So I'll divide by 2 to get the cos on its own, inverse cos on its own, and I'll cos both sides. So we get cos of y over 2 equals x minus 1, or x equals cos of y over 2 minus 1. Part 2 of D.
Add 1.
Plus 1. Thank you. Part 2 of D. Asked to find dx dy. So we differentiate this. Cos differentiates to minus sine, and we're going to get times by a half. So we become minus a half sine of y over 2. Constant differentiates to 0. Find the value of dx dy when y equals 2. Sub 2 into this. So we're just going to get minus a half sine of 1.